Okay, so we're recording. Um, and why don't we start? Because we're at 74 participants. So, so Jen and Ken, I win.
We're going to wait a few more minutes before we take the final tally.
Yeah, but I'm not going to let anyone else in. But still, 74. That's pretty awesome. So,
who's the speaker, Brian, today?
I will let them introduce themselves. Actually.
So I guess that's a good opportunity for me to start. Let me share my screen as well. Give me 1 second. Hosts have disabled. I think Brian, are you the host?
Yep. Have I?
This is Matt. If you could enable me for screen sharing.
Sorry, there we go.
And Adam will need it as well. Adam Tenkanow.
Yeah. Okay, you should have it now.
Okay.
Yeah, that is a new setting. They just added that.
Awesome. Here we go. So before I begin, I'll just take a minute to introduce myself. My name is Matt Manger. I co-founded CloudZero along with my friend and colleague Eric Peterson. Prior to CloudZero, I spent 7 years in the Air Force working in the information operations space as both an engineer and an ops lead. And after I got out of the service, for like the last 14 or 15 years, I've been working at different software companies in Boston in customer success and technical services roles. Sharing a little context about CloudZero and why we're here talking about Amazon Cost today. CloudZero is a cost management solution designed for engineering teams to automatically organize and surface information that's interesting to them. Since starting the company, I've personally been immersed in cloud cost. And today I work directly with a lot of our customers to help them understand their costs and meet their strategic objectives. During the talk, I really plan to cover a lot of the things that I see across our customers and the discussions and topics that we have conversations about as we work with them to strategically optimize their cost. The talk is about 20 to 25 minutes. I'll try and keep it on the shorter end. If everybody doesn't mind, if you could just hold your questions to the end, I'd be happy to answer anybody's questions. And following me, Adam will, so this is a more high-level talk, and then Adam will dive into a serverless system that he recently built, and his talk is more technical. Oh, and there's me. So standard agenda slide. We'll start with some high-level information about getting started and leveraging all the tools that Amazon provides. Then we'll look at some common areas where we see organizations accumulate waste. And we'll wrap up by discussing how to be successful with ongoing proactive cost optimization. So before we dive in, here are a few things that we're not going to cover. All these are awesome topics, but they either warrant an entire talk of their own, or there's something that we really don't see as a strategic part of cost management. So first and foremost, reserve compute. For most organizations, it's the easiest way to make a noticeable impact on what is probably one of the biggest components of your AWS bill. And with savings plans, it's really even become easier. A lot of our customers, especially those who are using savings plans, we see them using Amazon's tooling, which has gotten a lot better over the last few years. For those customers who are interested in more kind of automation as it pertains to reserved instances, we see a bunch recently using a company called ProsperOps. There's a number that are using SpotInst to kind of support those initiatives. But like I said, with savings plans, we see a lot of people even just using AWS. Next, there's Spot instances. You can save 70 to 90% off on-demand rates with Spot. If you're looking to get started or just optimize your Spot spend, I think everybody just uses SpotInst. We see a lot of people using them, and we see a lot of people very successful with that. And then finally, we have serverless. It's really a topic near and dear to our hearts at CloudZero, hence Adam's talk after this. Whether it's Lambda, Fargate, myriad of other services that support serverless architectures. Serverless applications have the amazing potential to be extremely cost efficient. There are pitfalls, certainly, many of which CloudZero has run into. But when done right, it's really a thing of beauty. We have more information in our resource center if you're looking for more information on serverless. And like I said, Adam is a wealth of information, and you guys can ask him all kinds of questions. So the cost optimization mindset. I want to start off with a few things to keep in mind as you think about cost optimization. A lot of people, when they hear that term, they think right sizing, they think shaving money off their Amazon bill at all costs. But it's really, it's bigger than that. You need to look at the complete context of what you're spending to begin down this process. So first, cost optimization is not free. And really what I mean by that is time. So why is that? It's because second, many of the optimizations that we identify for customers, they require buy-in from management, prioritization from product, participation from engineering in order to fix them. They're typically not quick wins. And the third bullet speaks to the real challenge with cost optimization projects or right-sizing initiatives. There's like so many complicated and oftentimes competing business requirements that making retroactive optimizations, it just takes a lot of planning, which then usually negates the benefit of making the change at all, right? It's a complicated topic. And this is why we recommend trying to think about your costs like you think about anything you do as part of your DevOps workflow. Proactive thinking about something or fixing something immediately is always going to be cheaper than letting tech debt build up. So before we get into specific cost savings areas, which I promise we'll do, let's start with some high-level best practices.
One question. I'm only just seeing best practices on the slide. Is your slide frozen or that's the slide we should be seeing?
Nope, it was just a quick setup. I'll make that note for if I give this presentation again. So the first part of best practices is setting yourself up for success, right? So it's ensuring that when you're ready to begin focusing on cost, that you have the configuration in place and the data you need. So to start off with, you should leverage AWS organizations and consolidated billing if you're not already doing that, right? It just makes things easier. The second bullet here refers to creating different AWS accounts for prod and development. Amazon will tell you to go even farther and create separate accounts like per feature or product. And that definitely can help with understanding your cloud spend, but it can be challenging to manage lots and lots of accounts at scale. As a general rule, separate out your production workloads from your development workloads at a minimum. And then where you go where you go from there, it's really up to you and your organization. Customers do a lot of different things as it pertains to accounts. The next recommendation here is tagging. Nobody likes tagging, but for most organizations, it's just really important. Tagging works best when there's a corporate policy setting expectations for engineering teams. If your company doesn't have one in place today, it's a great takeaway from the talk. There's some ways to make this process less painful. For example, CloudZero uses machine learning to automatically organize resources based off your existing tags. However, if you're going to effectively understand costs in AWS, you need to think about your tagging strategy. Once you've started tagging your infrastructure, you just want to make sure you activate all your important tags within cost allocation tagging so that you can actually use them in the Cost Explorer or really any cost management vendor that you're working with. I also always recommend customers enable the AWS generated cost allocation tag, which is at the top of the cost allocation page. And that's actually the page you see here, the picture. This creates a useful tag that's called AWS created by that shows which IAM roles are creating resources. So if you're looking to kind of investigate spend or why something's happening, that can be a useful tag. And then lastly, I'd recommend that everybody create an hourly cost and usage report if you don't already have one. Even if you're not planning to start thinking about cost optimization for like another 6 months, the majority of cost vendors need to ingest CUR data, and that includes CloudZero. And Amazon, they do not like to backpopulate them. So having the data ready when the time comes where you're ready to kind of focus on cost optimization is really helpful. The only thing to note is when you're creating your CUR, you just want to make sure to check the little box that says include resource IDs. Everything else should be approved as the default. Okay, some quick wins with the console and things you get for free. So Amazon has come a long way in their Cost Explorer and their tooling focused on managing cost over like the last 2 to 3 years. You know, if you had only engaged before that, it was challenging, let's put it that way. But I really feel like they've come a long way in the last few years. And we find that a lot of our customers are using the free Amazon services to manage the basics, right? Whether it be bill analysis, savings plans, coverage, or whatever. And then they use a tool like CloudZero because they like having a fast, simple way to understand and triage the cost of change in their environments without doing a bunch of manual work. You should definitely take advantage of all the available services to you that Amazon just gives you for free. So the image you see here is the main billing dashboard page, which is where a lot of the free services are available from as it pertains to cost. If we kind of just go down through this list. The top one is the Cost Explorer. It should be your go-to service if you're interested in slicing and dicing your bill and figuring out how you're spending your money. You got a lot of power in that tool and a lot of ways to kind of analyze your cost. The savings plan and RI tooling are pretty useful these days for planning and managing your reserve capacity. Next thing there, the budgets configuration. It's not my favorite service, but if your environment is pretty static, or if you have good segmentation of your spend across accounts, I've seen it used with some success. It can certainly get complicated to kind of leverage budgets at scale. So if you're really looking to kind of do a lot of budgeting, you might look for a different tool. And then the last item on this list is the Ec2 Compute Optimizer, which is a relatively new service, and it's not offered out of this area. It's offered out of the EC2 area. It's something that you'll need to turn on, and it's a great resource to help identify EC2 waste and perform those typical right sizing activities that you think about when you think about right sizing. So tagging, easier said than done. I really couldn't have this talk without at least having one slide on tagging. There's no getting around the fact that for most organizations, tagging is just a critical component of managing your cloud spend. I wish it were easier to manage and enforce, but it's just not. If you don't have a tagging policy, I highly encourage you to create one and to start setting expectations for the engineering team. It's offered at too early or too late really to think about tagging, and we kind of stress that with customers over and over again. If you're looking for some guidance on what tags is standardized on, I would say these are the 3 most common tags we see as a part of those tagging policies or strategies that I talked about. So the first one is a tag aligned with the service or application that a resource supports. The second one is a tag corresponding to the environment that the resource is being deployed into. And the third is a tag identifying what person or team is responsible for that resource. So if nothing else, I would recommend you kind of implementing those tags as kind of your standard tags. Most development teams today leverage some type of CI/CD, and/or infrastructure as code tool. And they're a great way to tag newly created resources into an, oops, is there a question? Okay. So those automated tools are a great way. Can you hear me? Oh, I can hear you.
Yeah. How's it going?
Good. Question? Nope. Okay. So those tools are a great way to tag newly created resources, right? Because they can be set for all resources as they get deployed. For existing resources,
okay. Sounds good.
For existing resources, there's usually a manual process to get them tagged. And we always recommend starting with the most expensive ones because there could be a lot of resources that are untagged. And throughout the process of tagging, you just don't want to forget about supporting resources either. And by this, I mean things like EBS volumes or snapshots associated with EC2 instances. If you're looking for help to maximize your existing tagging, there are certainly tools out there that can help you boost your tagging coverage, with CloudZero just being one of them. So now for the exciting stuff. Let's explore the common areas where we see waste within the organizations that we work with. You'll notice that I use the term in the header here, architectural waste. Since a lot of kind of the waste in these areas comes from choices that were made during the initial design and development of an application. And CloudZero refers to this excess spending coming from many of these categories as cost tech debt. So like any tech debt, some choices made, they may have made sense at the time, or they may have been like a quick fix to an urgent problem, but they just aren't scaling with your business in a healthy way. These things aren't necessarily quick to fix, and they have to be planned for just like any other tech debt reduction activity. So why does cost tech debt build up? So that number one is the reason pretty much any tech debt builds up, right? There's always time constraints in engineering, and there's always just competing priorities. And the second two are kind of more focused on cost. So the first one is typically engineers don't have visibility to the costs of features they're building, or really tools to give them relevant and timely feedback to the cost of the systems. And then that third bullet is probably the most strategic, is that cost isn't usually a non-functional requirement that's considered during the design phase, like performance or security would be today. Imagine if an engineering team knew that the service they were building couldn't cost more than $1,000 per month based off some production workload. It certainly would impact the decisions they made when they were designing their systems. Engineers really thrive on data, but they often don't have access to the cost requirements or cost feedback during that development process. And that's really what we have to change. So now into the areas here. First one being snapshots. As I talk about these different areas, there's going to be 4 sections to each one of the slides. First I'll talk about a quick description of what it is. Then I'll talk about symptoms of what we see in environments and why we might bring it up to a customer. The next area will be typical causes. And then the final one is, what can you do to remedy this? So again, first one is snapshots. Stored snapshots are used by a number of services as a backup mechanism. So nearly all customers will spend some amount of money on snapshots. So that in of itself isn't a problem. It's when we see customers spending like 5 to 10% of their monthly bill on snapshots, or they have just like really old snapshots, that will raise this as an area of concern or an area that they could potentially optimize. So for causes, in most cases, snapshots build up because there were just never non-functional requirements around backup and recovery, right? This leads to either conservative defaults being left in place or no explicit lifecycle policy being created. For applications that were built before 2018, snapshots had to be manually managed, which means that today we see all these really old snapshots because there were never deletion policies that were put in place, right? So what we're going to see as a solution is really leveraging Amazon's Lifecycle Manager if you can. If you're already leveraging the Lifecycle Manager and you want to change a retention period, it can be a relatively quick win, kind of depending on the service. If you're not using the Lifecycle Manager, it's a good service to explore. But regardless, like the business needs to set retention requirements for the engineering teams, right? And sometimes that's per application or per service. When we go into organizations, we frequently see retention periods of 7 to 14 days. That's not to say we don't see longer, because we do. But on average, I'd say we kind of see 7 to 14 days with most features or most products. And if you're a customer with lots of old snapshots, you can consider whether these are even required to keep, or if there's a lower cost storage option that's available instead of maintaining the snapshots. Okay, next area, previous generation compute. It's a tricky one. Previous generation compute is compute running on legacy AWS infrastructure. It's an easy one for Amazon and vendors to highlight. We do. But it's not always an easy or a practical one to remedy. If you can migrate to the current generation hardware, you can usually see cost reductions of anywhere between 5 and 20% depending on the service. And you also get performance improvements to boot. But like I said, it's not always an easy one to remedy. So we bring this up to customers if we see more than 10% of their compute, which is not tied up in our eyes, is running on previous generation. That's when we'll bring this up. Because almost always you'll see some amount of compute running on these previous generations. But like I said, we don't bring it up unless it's 10% or more. And then there's really two main causes of previous generation compute. And I think these speak to why it's complicated to fix it. So first one is that once an application or service is in maintenance mode, moving to new hardware requires lots of testing, right? And those kind of maintenance mode applications typically don't have testing as part of either the budget or the testing cycles associated with that application. And then second, many times, the previous generation compute is tied up in reserved instances, right? And the customers, especially if they're not convertible RIs, the customers don't want to lose that coverage, right? So either of those two instances or a combination of them is what makes this one kind of an easy one to identify and a complicated one to potentially remedy. And the only real action to do is to evaluate what resources are running on kind of previous generation compute, and that's relatively easy. And then just going to look at the new rates for the current generation. And then you can see the savings that you would get. And really, it's just a business decision, right? Is the savings worth the effort to do the testing to move to the new hardware? So this next topic, NAT Gateway, it might be my least favorite topic. Amazon's NAT Gateway makes it easy to securely connect to the internet from a private subnet and a VPC. And you pay for usage hours and you pay for gigabytes passing through the gateway. The fact that it's managed and easy, I think, is why a lot of people use it. So again, we see almost all organizations using some amount of NAT Gateway, so that in of itself is not a problem. But usually we'll bring this up as an area of potential savings opportunity if the cost you're spending on that gateway alone represents 5% or more of your monthly spend or a feature or an account spend, that's when we'll bring it up to a customer as something to potentially optimize. So what causes it? Data transfer causes it, right? It's usually not the hours that are going to drive crazy net gateway charges. It's the data going through it, right? And data transfer in AWS is just complicated. It's hard to understand, right? And when an engineer is building a system, it's hard to understand how much data transfer is going through that gateway at any given point, but it's certainly at scale how much data transfer is going to pass to that gateway, right? And this is what kind of leads to architectures that, once fully deployed or a year or two on, will have net gateway charges that can be excessive. So if you find yourself with excessive net gateway spend, it's not a straightforward do this to fix it. The best thing to do is to visit, a blog and try and kind of run through the steps. CloudZero has one that you can review. There's a lot of people have them. The process really involves first using flow logs to analyze the data transfer through the gateway, and then exploring alternatives like VPC endpoints, depending on the architecture and kind of the services that are being leveraged. But again, it's not necessarily straightforward and not something that might make sense. And usually it's not until you start spending X%, 5% more, where it makes sense to look at that. So we went from one of my least favorite topics to one of my most favorite topics. S3 is next. I love S3, it's awesome. It's a service offered by Amazon that provides object storage. When most people think S3, they think primarily about storage, which makes sense. There's actually 3 different cost drivers for buckets. There's storage, there's API activity, and there's data transfer. So there's no hard and fast symptom of S3 waste. There's not like a percentage that says that you're wasting on S3. But typically if a customer is spending more than 10% of their overall spend on S3, we'll work with them to at least understand why they're, what they're spending money on: storage, API activity, data transfer, expensive buckets, etc., and help them identify cost-saving opportunities if they exist. So why does atypical spend kind of happen in S3? I think it's because S3 is one of the oldest services at Amazon, right? A lot of people use it, and a lot of people just use it, in a lot of different ways. And this broad applicability is what leads to, some costly S3 buckets. There's also just a number of storage classes within S3, and not everybody understands all the different storage classes. And then there's intelligent tiering, but really that came out in 2018 or 2019. So there's certainly lots of really old buckets that came out before that was even an option. So what to do? What to do depends on what is driving the cost of a bucket to be really high. If storage is driving your S3 cost, then we usually will recommend turning on S3 data analytics for the bucket. The feature brings a minimal cost, but after a few days, Amazon will make recommendations to optimize the tiers of your storage. There's also intelligent tiering if storage is driving your cost that you can explore. I would say don't go willy-nilly just turning on intelligent tiering, because if you have a really expensive bucket, it can be expensive to turn that on, especially at first, but certainly an option for you. If API activity or data transfer is driving your S3 cost, it's a bit harder. For API activity, you really need to analyze the activity hitting the bucket and then work with engineering to explore optimizations. If data transfer is driving your cost, you can explore cache control headers on the files within the buckets, but oftentimes, again, it's just going to require engineers and engineering support to kind of help identify what's causing all the data transfer costs. Depending on your usage of S3, there's also other services at Amazon that we've seen customers have success with, like DocDB. So Amazon has a number of services that are used to help or understand other services or resources. And CloudZero calls these the Amazon management or AWS management services. And we typically will include CloudTrail, CloudWatch, and Config when we perform our analysis. But sometimes for some customers, we'll lump other things in there, guard duty or X-ray or inspector. I mean, there's other things we'll lump in there too, but the big ones are CloudTrail, CloudWatch, and Config. So we look for accounts that are spending 10 to 20% of their overall spend on these management services as a sign of optimization opportunities. And I'm actually going to show both of the causes and the to-do bullets here, because I'll talk about each one of those services individually. So for CloudTrail specifically, if we see like any more than a few $100s per month, it's usually waste that can be addressed. And organizations, you'll get one free trail per account, and after that, you're charged per trail. And in most cases, an organization only needs one organizational CloudTrail. And after that, you can explore removing the extraneous ones. There are exceptions to that rule, right? But typically, as soon as we start seeing a lot of CloudTrail costs, it's an easy optimization to do. The next one is CloudWatch. And that really varies a lot more per organization, whereas CloudTrail is very typically waste. CloudWatch varies. More native organizations or more native applications will typically spend more on CloudWatch, which will drive higher percentages towards 20%, which is not necessarily wrong or bad. High CloudWatch charges are typically a result from a few expensive logs or something making excessive get metric request API calls. And the solution usually involves looking at CloudTrail to identify the problematic actor and then working with engineering to understand why it's doing that or why it's doing what it's doing and how to remedy it. Also, if you turn on something like flow logs, that will get manifested in CloudWatch. So it can all of a sudden lead to high CloudWatch charges. But again, looking at the resources is an easy way to figure out what's driving your CloudWatch costs. For config, config's an interesting service that we see some customers like, and a lot of other customers think it's kind of more expensive than the value that they get. So config's cost scales based off the number of resources in an account and the number of rules you have configured. And if you have a very dynamic, lots of auto scaling, lots of Lambda, like an environment where there's these lots of transient resources, config spend can actually be quite high. So it's one of those where you don't have to turn it on in all of your accounts. And if it's something that's driving thousands of dollars per month or even sometimes hundreds of dollars per month, you might just ask the question whether you're seeing the value from that, from the cost that you're incurring. So this one will be a quick one, DNS queries. We don't see it too frequently, but we do definitely see it. Amazon's Route 53 service, among other things, will connect user requests to infrastructure running on AWS. Engineering teams don't always realize that you pay for DNS queries. Like everything, there's no hard and fast symptom here, and it really depends on your spend. As a general rule, I'll bring this up with customers if they're spending like more than $250 per month on DNS queries. The main driver is usually an org with lots of publicly available infrastructure, although sometimes it more directly results from kind of an engineer doing something that they didn't know would drive so much cost. The interesting thing here is if you're spending hundreds or thousands of dollars performing DNS lookups, it probably equates to like billions of requests, right? So you get so many for free, and it's not until you kind of reach different tiers of numbers of these things sent that the charges really start to rack up. And the answer, like a lot of categories, if you see yourself with a bunch of DNS spend, is to work with engineering to understand why, or ops to kind of understand why. And it can usually be optimized, but can't usually be removed once you've identified why something is sending a lot of DNS requests. Last but certainly not least, I call them the waste top three. These are the classic areas that vendors surface as potential waste and right-sizing opportunities. Most commonly, these recommendations are for idle EC2 instances, idle RDS instances, and unattached EBS volumes. When I'm talking with customers, I like to refer to these as like death by 1,000 cuts. Without proactive measures, this type of or underutilized resource, it just accumulates. And they're typically not high dollar observations, right? But altogether, they can represent decent savings. That's the problem though. There's normally a number of these, and each has to be researched to determine the business impact of removing or right-sizing the resource. As I give customers like lists of these things, generally they'll tell me that the effort to triage the list, it outweighs the savings they might get, right? Which is typically what happens is we give this list, and then we either will agree that we'll just focus on like the top X, 5, 10, or they just set a dollar threshold, right? We're only going to look at things that might save us $100 or where we're spending more than $1,000 or something like that. It's always a prioritization effort as it pertains to these. And then with regard to what to do about this type of waste, my answer to customers is always to be proactive about monitoring, right? You'll need to use CloudWatch in most cases. You can use the EC2 Right Sizer if you're looking at, or Amazon's EC2 optimization service I referenced. But for EC2, you're usually looking for, low CPU, network, and memory. For RDS, it's more about connections and then CPU. And then EBS is a little different. You can actually find unattached volumes right in the console. But you might use CloudWatch to also search for instances that have attached volumes, but no IOPS, which is like, disk IO. And I guess I should put a quick public service announcement here that before you go deleting anything, just make sure you don't need that data. I've definitely seen lots of customers get a little too aggressive when deleting things. So the last few slides was all information about what to look for and how to reactively optimize. I mentioned previously the challenge with optimizing after the fact. So now I want to take a few minutes just to advocate for proactive cost optimization. And this is kind of the area that we're really working with our customers to strategically address. So we're constantly, in nearly every customer, working with organizations to embrace a cost-conscious engineering culture, right? They realize that engineers are making buying decisions daily as it pertains to AWS. And this could be in the architectures that they're designing or the instances that they're starting. And the only way to really strategically control cost is to empower those teams, right? And then hold them accountable for cost, just like they're held accountable for performance and security today. And like the solutions to many business problems, creating a cost-conscious engineering culture takes a combination of, the classic people, process, and technology. And the people here would be the engineering teams embracing the challenge, the product teams recognizing the non-functional business requirement of cost. The process piece is all about building a culture around using standard families and sizes, not always, going for the memory optimized, and always, looking for conservative defaults. As a rule, it's typically easier in Amazon to increase performance than it is to decrease performance. And the technology piece refers to operationalizing that cost metric, right? And giving engineering teams, and really all teams, access to the right information in a time frame of relevance for them. How can engineers specifically be held accountable for cost of the systems that they build and maintain unless they have targeted that real-time feedback? And in short, they can't, right? And really that's what we're looking to solve with our customers. And then last slide is really about the strategic conversation we frequently have, right? And that's about managing your cloud investment, not just your cloud cost. Change is a constant in AWS, and everybody I feel like resonates with that. And organizations struggle to understand, what cost changes are meaningful to focus on. Cost going up isn't necessarily a problem if the revenue or if the KPI for a product or feature is going up or down, I guess, for a KPI's perspective faster. But it all starts with understanding how much your features and your products or your teams are costing. How else are you going to evaluate the business priority around change? Aligning cost to features and products has traditionally been really difficult for a number of reasons, some of which are listed kind of in that box. We already talked about tagging and having numerous accounts being hard. There's also the reality of shared infrastructure and containerization, which makes apportioning costs to specific features or products non-trivial. These challenges, they need to be addressed before you can start to dynamically understand the costs of products or features. And at a tactical level, it really comes down to having the necessary process and tooling in place to be able to hold your teams accountable for cost of their features and products. Here are just some examples of the questions that we hear from different customers working on that people, process, and technology that I was talking about. Because it's a journey for all customers, right? Very few customers will go in and just have all this, on day one. And for engineers, it's asking questions like, what's causing the cost of my feature to grow and shrink? Right? What was that activity that caused this little blip in the costs? For DevOps, it could be, are the costs of our features or products trending acceptably per some type of business projection? And then for product teams, it's likely answering questions around the cost of the products to support either COGS or margin type analysis. And having a cost-conscious engineering culture and understanding the costs of your features and products, it really serves as the foundation of what will let you start to actively manage your cloud investment and ultimately control costs in perpetuity, right? Not just having an initiative to do it. So with that, that is kind of a practical guide to optimizing your costs. And I will take any questions that people have. And I guess I can look in the chat too. I don't know if there's.
I'll jump in. I've got a couple of comments and questions. I think this is spot on. I'll say at my last place, at one point during a cost sweep, we found 4 petabytes of volumes that no one knew we still had.
That wasn't costing too much, was it?
No, but actually a question that goes along with that, in that, or maybe it was snapshots. AMIs tend to be backed by snapshots, and so one of the things we discovered was that we had a lot of snapshots, and it was hard to tell if we could get rid of the snapshots, because it was hard for us to know whether they were associated with an AMI that we might still be using.
Yep, absolutely. I mean, there's just a lot of, as soon as you start talking about let's call them the child resources, right? The snapshots, the volumes, some of these things that aren't the classic like instances, it can be hard to understand the relationships. And it's one of the things we hear over and over again with our customers. And we certainly, use our platform to try and help expose those relationships to customers to kind of make these analyses easier. But you're absolutely right, Brian. It can be difficult to understand that. And you really have to understand the relationships between resources. And you need a system to help you do that.
Right. Well, I told them just let's go to Lambdas and not have AMIs in the first place. But another question, if I could, but anyone else jump in. In terms of the costs with RDS, we found going to Aurora auto-scaling to be a really good approach, because our application had a lot of time periodicity to it. So it was okay for us to have Aurora auto-scale down the instances at night and then come back up. And so I always advocate Aurora and then Fargate.
Yep. And Adam or Eric, I don't know if you guys have any comments to that of what we've seen in our own architecture. I'm not an engineer, so I don't understand to that level kind of what the engineering team does.
Yeah, we use Aurora as well. And for the similar reasons, right? Bursty kind of load. So we find it to be very helpful, right?
Yep.
Hey.
And then I see a question in the comments. And it says, when we first start working with customers, what do you put in place? So I would say there are 2 things that we do with every new customer that we start with. We have a feature that we call product mapping, which uses ML to try and support the process of mapping your AWS infrastructure to business concepts, right? These could be features and products. These could be services and teams. But the first things we do are trying to get that mapping in place of your infrastructure and trying to figure out how to improve tagging to support that, right? The ML, it does a great job of kind of getting you farther than you were, right? But you still can't get around the fact that if you really want to optimize cost and perpetuity, that you have to have a tagging strategy to support however you're rolling that cost up to, however you think about aggregating cost. I hope that answered your question. But it's definitely mapping cost to features and products and tagging, right? And then there's other things like CloudZero you just get out of the box, like anomalies. So certainly customers are always thrilled about that, but from a strategic perspective, it's all about mapping your products and it's all about tagging.
So I'm aware of several engineers that I've been friends with who are sort of forbidden from seeing their AWS billing console. So do you, when you're having a relationship with a company, do you advocate that all the engineers sort of see the nuts and bolts for the costs of?
We typically do not weigh into that conversation. And it usually has to do with if a company is public or not, right? And a lot of the public companies that we see don't want people to understand all of their costs. So typically it's a company thing, right? So we support 2 different modes, right? We'll support a mode where they can see everything, and we'll support a mode where they can only see the infrastructure aligned to the features and the products that are associated with the teams that they're a part of, right? But we don't weigh into that discussion.
Hey, Matt, so just first off, that was a really great talk, so thank you. You mentioned a bunch of the, the free AWS tools. You didn't, I didn't notice you mentioned Trusted Advisor. Do you have a particular opinion on the utility of Trusted Advisor?
So I see customers, it's almost like config. I kind of lump them together. We see customers who use Trusted Advisor and it can give great recommendations on, a variety of different things. It can cost money, right? And sometimes it's a non-trivial amount of money. So that's another one where we see customers turn it on, but once they see the bill, some customers leave it on, maybe security wants it on, maybe DevOps wants it on, and other customers will turn it off. So I kind of lump it kind of in with config, and there's value there, but there's a question of whether the value is worth the spend depending on your architecture. So let's see, I think there's some more questions in the chat. Or does somebody have a verbal one, and then I'll answer the chat questions?
Sure. I just wanted to point out what I call the reserved instance trap, where if you think you're going to be using an instance for 50, 60% of the time, and you say, okay, I'll just buy a reserved instance. Or we also had a lot of money sometimes sitting at the end of the year, and so what do you do with it? Well, buy some reserved instances. But the trap comes in, if you're not using it all the time, it's kind of wasted. And then the other part is, if you have an application that could benefit more from spot instances, but you've already paid for the reserved instances, now you're kind of trying to schedule people into the reserved instances rather than just letting them do the work on the spot, as it were, with spot instances, where it can be done a lot quicker and ultimately more cost effectively. And we had one project where we had 10 reserved instances, but we were spooling up clusters of 100 or 200 instances. And of course, the percentage utilization of your reserve, yes, those individual reserves are at 100% capacity, but now you're using 90 or 190 extra instances that you hadn't accounted for initially. So it can be deceptive.
Absolutely. And I think so CloudZero as a company, we made a strategic decision early on that we were not going to focus on reserved instances, right? Our perspective is Amazon does a pretty good job at it these days, and there's other vendors who specialize in that. But what you just commented on is the whole reason why it's almost a futile challenge to try and project what reserved instance you need, right? Because so much of it depends on what the business is going to do in the next year, right? It's impossible for an algorithm to know, hey, we're going to try and convert one of our biggest workloads to spot, right? It's challenging.
And then if you change the architecture to serverless, well, that tosses the reserved instance.
Yep. So let me see some of these questions in the chat. Is there a naming convention you would recommend? So for tags, there's not necessarily a naming recommendation. Adam, can you speak to what our naming convention is for tagging?
Yeah, so we do I think it's semi-standard, prefix colon something. And we follow kind of the guidelines you talked about, right? So we do every stack that we deploy, we always deploy through CloudFormation or serverless application model SAM. And we tag everything that we can with CZ colon, CZ prefix for CloudZero, then a namespace. And namespace is kind of like an environment to us, or with the team, right? My team, Anomaly's team, or and then finally the name of the feature, right? So we apply all those tags to all our stacks. And I find that the colon delimited tagging is nice because there's going to be a lot of other tagging that ends up in your account, kind of whether you like it or not. At some point, you'll get some other vendors or Amazon itself will apply tags. So the prefix is definitely nice to have.
Yep. Okay. Next question. How do you guys compare to Cloud Health? So I would say that as CloudZero compares to something like Cloud Health or Cloudability, name your kind of cost management vendor. I would say that it's my opinion that those technologies were really built to support a financial use case. And they do a great job at letting you slice and dice your bill in a million different ways and, report out and, all that kind of stuff. And I would say that CloudZero you know, from day one has been built with kind of the engineer or more technical audience as the primary audience. So our platform is much more around how things are changing and how we can proactively alert people to change, recognizing that, you know, cost is not going to be their number one priority on a day-to-day basis, right? How can we enable technical teams to really operationalize the cost metric? So that's kind of, you know, that's how I would say that our kind of our platforms differ. Let's see. That is for tagging, I assume. I don't know what that was a part of. For serverless apps, are there tools that show you the cost of having less than performant code? How much extra you're paying? So Adam, that's a good question for you. I think X-Ray helps you with the average load times. I wonder if there's a way to build on top of that to get the dollar value.
Yeah, so there are definitely ways, and CloudWatch or CloudWatch Insights or CloudWatch Logs Insights is a helpful tool there. In fact, we have had some POC features where we built on top of those to explore the waste spend. I love X-Ray. I definitely think if you're serverless, you should be using it, and it's definitely a helpful tool.
Do you have a channel program? So we do have a few channels, but more frequently we're working with kind of customers directly. So again, we have a few partners, but more frequently we're selling direct to companies. I think that's what that question was asking.
Okay, I was thinking since we have another talk, maybe we should wrap this part up.
That's perfect, because Adam is actually way more entertaining than I am too. So this is a good transition.
That is a fact.
But Adam, before you start, we're gonna do our first raffle question. This is for so we're gonna ask a question now for one of the $25 cards. Then after Adam's talk, another one for the $25 card, and then at the end we're gonna post a survey, and the first person who answers the hidden survey question gets the $75 pizza question. So I'm going to ask the question, and then the first person who gets it in the chat wins. And I'm actually quite happy with this question, but I am just such a sci-fi geek. So the question is, in sci-fi, which fighter has more engines, and how many are there? A Battlestar Galactica Viper or a Babylon 5 Star Fury? And we have a winner, Federico. Oh, but wait a minute, you didn't say how many. You got to say how many.
Oh,
I'll say that makes it a little bit too easy.
that wasn't the question.
Okay, he got it. Okay, Federico still got it. So Federico, send an email to me, briantarbox@gmail.com, and I'll send you the gift card code. Star Furies have 4 engine, Vipers have 3. So,
Woo-hoo!
yes, so say we all. Okay, Adam, all yours.
That Let's see if I can share my screen and share the right screen. That's going to be the hard part. So let's do that. So that goes there. Got it. Share. And I want to share that one. Okay. Come on, Zoom. All right. So can everyone see just the presentation? Is that a yes? Cool. Excellent. And can everyone see me? Because I'm pretty animated and I'm going to move around, and maybe that's part of the entertainment. So
Yeah, I can still see you.
Cool. Excellent. And if I step on my cat, that I apologize to the cat. So before I start, I just want to say thank you to everyone for being here, for spending time with us tonight. Thank you to Brian, Ken, and Jen for inviting us. And I hope everyone and your families and loved ones are safe. And it's a trying time right now. And I'm happy to spend this time with you to learn from each other. So without further ado, if everyone can see the head slide. Let's see here. So do I have enough buzzwords in the title? Do I need more buzzwords? Well, let me know. So that's me. That's taken at reInvent last year. That was after a few days on the floor. I was a little discombobulated. You can find me on the internet in some different places. I am a certified professional architect. Did that at reInvent last year. That was a lot of fun. I love serverless. I love Lambda. I love pure functions. I love data. I love functional programming. Those are things I'm passionate about. I live in a tiny semi-rectangular town in central Massachusetts. You can probably find me if you squint or if you Google enough, right? And finally, my name is Adam. Okay, I got some big audacious goals for this talk. And these goals are to teach you how to productize an ML pipeline. And specifically, how not to use the AWS service limits. A new way to use the pricing pages. A new way to constrain your systems. Tips for actually productizing ML code. And finally, a new operational metric that I think you should make part of your DevOps teams. And at least you're going to hear some funny stories and get some good references. So my journey to this talk starts kind of with me reading this blog post. And I'll link to it at the end of the presentation. And if any of you are anything like me, when you read a blog post, you get a certain feeling when things just aren't right. Here's the TLDR. I'm not going to go through all these things. I do think it's a good post. It's by the Andreessen Horowitz team in their blog. Please read it if you're interested in machine learning and startups. However, my takeaways were these specific words they used in specific parts of this blog post that made me feel really skeptical. So things like an AI model can cost hundreds of thousands of dollars, or model inference, which is prediction, right, is more computationally complex than traditional software, like reading from a database. Now, if anyone here uses Dynamo or has built their own relational database, I think you'd argue with that statement. It's a little reductive at best. And then finally, cloud operations can be more complex and costly than traditional approaches. And again, I'm just incredibly skeptical anytime someone says this. It sounds like one of those bad baseball statistics where you are narrowing down so that you're special. I just don't know. I'm skeptical of it because it probably means you haven't looked at prior art. And it probably means that there are things that you're not taking into consideration, because people have been doing some pretty amazing things for a long time. So I'm going to use the Alexa voice remote and at times this Fire TV stick kind of as my framing device. By the way, does anyone else have like 1,000 of these? Like they just multiply in my, these are ones that I'm not even using. These are just, I don't know, well, they're around, so they're part of the talk. Anyway, so this device is really cool form factor. And I'm going to make a pandas joke. Does everyone here know Python? Well, anyway, so pandas is like the de facto data science library. And I'll tell you right now that in order to get voice recognition on this remote and the processing that goes in, doesn't start pip install pandas and then it's on this device, right? There's a lot of steps in between. And maybe pandas was involved, but I doubt there's even 150 megabytes on this little remote for pandas. But the point is that there's a process of productization. And I'll tell you a little bit about my history. So back in the day, I worked for Dolby in San Francisco. And this Fire Stick is rated to decode AC3 and EAC3, Dolby Digital, right? Dolby Digital Plus. And what is the process for getting Dolby Digital Plus on this Fire Stick? Well, it involves my old team when I used to work there. And that process looks something like this. Research comes up with an idea for some great algorithm, right? The research team says, hey, how do we turn 2 channels into 7.1 channels of audio? Let's do that. And so they come up with an idea. They probably use MATLAB to do it. And then they slip this dirty napkin under some doorway, right? And there is another team. That team is just working away, changing that MATLAB code and that crazy code into, for this, embedded C code, right? So that can be ported to a device. But it doesn't even get to the customer then. After that, they hand that code to another team whose job is just to wrap up that code and make it look really nice and serve it on a nice platter to the licensee, in this case, Amazon, right? So once that team hands that delicious package of stuff to Amazon, then Amazon has probably a team or two that's getting it to work on this device. And then it goes back to Dolby, to the teams I worked on, which is the implementation team, which is the team helping you get this onto your device, helping you implement it. And then you have to send an example, one of these, back to Dolby in order to, for us to do tests, right? For them to do tests to make sure that it's rated for Dolby Digital. It does everything right. You implemented the algorithms right. So you're talking about no less than 5 teams at Dolby and probably 2 or 3 or more teams at Amazon making this work, right? So again, there's a lot of steps between pip install, Pi audio analysis, and like Fire TV stick. So I just want to belabor that point a little bit, right? That's a process to get it to work on a form factor like this. Now, in the last 10 years or so, working in engineering, working with AWS for at least 6 years, this is what productizing ML looks like nowadays. There is a Jupyter notebook. For those who don't know, Jupyter notebook is basically like a REPL or just a fast interactive UI for working with pandas and other data science frameworks. And usually you're manually loading production data into this, and tuning your meta parameters, and then it's like jam it on an EC2 instance, point it at prod, and you walk away. This is kind of a joke. I don't know if anyone knows I think the X1E 32 extra large is the most expensive EC2 instance type, but maybe we can take that offline at the end to be another like question. So that's what I see a lot, right? Is because it's hard. Machine learning is kind of an art, and so you've got to be tuning these parameters, and then once it works, you don't want to touch it or even look at it, and so you just throw it on an EC2 instance and walk away. So our story. So the story I want to tell you now about how we productize ML. Where does our story start? Well, it starts with an EC2 instance and a Jupyter notebook. Actually, it was a smaller EC2 instance. We're not animals here, right? It was just a T3 2x large, which was only 30 cents an hour. And we had some Python modules. It wasn't just a notebook, but we were definitely just SSHing them to that machine as we went, right? And I got to be honest with you, I'm not here to condemn that. That's how you should start, right? Because again, data science is an art in a lot of ways, and the data science team should have a safe way to run with scissors against production data in order to find out if there's value in the algorithms they're exploring. Because at the end of the day, that's what they're trying to do, right? Is to discover some business value for your business. And so you do want that to happen, and that's fine. However, once value has been determined, then it's time to follow that model that I talked about with like Dolby and the Fire TV stick. Now you need to productize it. And so how do you start? Well, kind of logical way to start is, okay, the data science team calls a meeting and they present to some engineering team what they did. And they show them the code or they show them how it works. And I think this is a really dangerous path. It's a dangerous path because that engineering team will anchor themselves to certain assumptions. They will look at the code and not be able to unlook at that code. And they will start to think about how much data does it need? How much compute does it look like it needs? What libraries are you pulling in? And then the next logical step for someone like us who's building in AWS will be, oh, what AWS services and service limits allow me to port this code to AWS? And I just think that's really dangerous, right? Tip number one, AWS service limits are not your primary productization constraints. You do need to know about them and you should care about them, but they should not be your primary constraints. First reason is there's lots of ways to solve something in AWS. So why are you looking at the limits before you kind of think about the tools and what they functionally do? But more importantly, it's just the wrong focus. It's the wrong focus for your business. So if the service constraints aren't your primary driver, then what should be your primary driver? So I argue that your primary driver should be customer-focused design, guided by, this term I'll use is transactions. So when I say transaction, I'm not talking about a database transaction. I am talking about a value that your user gets from the system. So that, for example, if I'm using the Alexa voice remote, it might be me hitting the button, it beeping, me speaking, hey, I want to watch what's that show, Lion King? I want to watch, Tiger King, and then it's showing up on the screen. So that's a transaction with your system, right? This comes from the book Release It by Michael Nygaard, which I highly recommend everyone read. And so when you have a transaction of value for your user, then you can kind of reason about what your system needs to do and how it provides user value. So my recommendation is to get in a room with your data science team, with your product team, with your engineering team, whoever needs to be there, and hammer out customer-centric metrics for data science. So for us, when we were productizing, I got in a room with the data science team, with Matt, with Eric, and we said, what do we want to do? In our case, we were trying to predict cost anomalies. And so we figured out how often we wanted to do that. We figured out how knew how often we got new data, how often we wanted to do model building, training, and prediction. So we kind of came up with all those metrics, figured out how often we wanted to send that data to the customer. And at the end of the day, we kind of came up with 3,000 transactions per day. That was this number. At the time we built the system. So we kind of settled on that. It's like, oh, okay, 3,000 transactions with this system a day. Great, that's some user value we can reason about. So, great. We have some customer-focused domain metrics for training and prediction. But now what? Okay, who remembers procurement? So, I mean, I think Michael talked about this a little bit before, but you know, when you do reserved instances, it's kind of like that. You know, I used to work in speech recognition, and every year we would predict how much the farm would grow, the speech recognition farm, and how much we needed for our system. And we would tell our VP some number, right? We would say, oh, we need that number. We'd multiply by 5, of course, so that, because we were going to get less than what we asked for, so we'd get something. But you know, you do this calculation, you figure out how much you can afford, right? And you know, maybe you just need 1,000 servers. But what's really interesting about that is when I think about that, at the end of the day, they would give us some amount of money that some VP or CTO approved, and we would get 1,000 servers or n number of servers. And then that was really kind of cool, right? Because now we had to fit whatever we wanted to do in that year on those 1,000 servers. That's actually a really cool constraint, right? That's kind of where a lot of performance requirements come from, the performance ones that are not directly customer facing. But it's like, how do I get this to work on this tiny, you know, or these 1,000 machines that they gave me? Well, that's kind of tantamount to, hey, you know, production team, you got to fit that on this clicker. Like, you got to fit on this clicker. You got to fit this on this clicker, right? Like, that's cool. You got a physical form factor that now when you go to productize, you need to meet. So I told you before, I think that a cost constraint is a good way to start. And I told you before that you need some sort of number of transactions. For us, it was 3,000. So how do you go from some money to the number of transactions you can afford with a given service? Well, to be honest with you, the pricing pages are not built to do that. Not at all. Like, all of the pricing pages output the total cost of your system, which isn't really great to tell you how much of that you can afford. That's not really what it does. And honestly, I don't think you should spend any time calculating the total cost, because the Cost Explorer does that for you as soon as you put something into dev or product. Just let it do it for you. So instead, what I recommend is do use these equations, but invert them so that on the right side of the equation, you're getting out the number of requests. So you can do this with any Amazon service. However, it is much, much easier to do it with serverless services whose focus is on a request or a transaction or, you know, a step function execution, or even on, you know, Dynamo on-demand pricing, where it's just how many writes. So I'm just going to go through this example with Lambda just to frame this for you. So Lambda cost is request cost plus duration cost, where request cost is this constant times the number of requests. And the duration cost is this constant times total gigabyte seconds. Now, what's interesting is when you think about total gigabyte seconds, you realize that it's actually just a factorization of number of requests. So total duration is just this constant times the number of requests times the average gigabyte seconds per request. This is great. Okay, so now we've got requests all on the right side of that equation. And if you substitute this duration cost and the request cost back up in the top, factor out request cost, you'll have total cost on one side, request cost times something on the other side. So you can divide both sides by that other something. And what you'll get at the end is requests equals the total Lambda cost divided by these constants with gigabyte seconds per request in the denominator. So, okay, Adam, what does this mean? Well, before I told you that we had this EC2 instance, and I think it was like a T1 4x large. So how much does that cost? It's 30 cents an hour. You do the math, you come up to how often we were running it. At the time we started implementing, we had about $7 a day in this cost. So let's just, to use that as an arbitrary starting point, put in $7 as our goal for cost. Now we can use gigabyte seconds per request as our independent variable and number of requests as our dependent variable, and graph those, just putting in a range of values for the gigabyte seconds per request, and just see where that lends us, right? So this is kind of the graph of what you can get in Lambda for that number of gigabyte seconds per request. And if these were log scales, you'd see it's perfectly linear relationship. However, what's interesting about this? Well, recall that I told you that we need about 3,000 transactions per day for our system in order to have the business value we want. So let's just go find 3,000 on the number of requests fulfilled. And we find ourselves with about 128 gigabyte seconds per request in Lambda. So that's what we can afford on this basic $7 a day budget in Lambda alone. Now, I want to be clear, if anyone here knows Lambda, right, I'm not saying 128 is the lowest memory setting you have. That's not what I'm saying. I'm saying it just happens to be coincidentally the same number, but a gigabyte second is giving that Lambda a full gig of memory and then letting it run for a full second. So that would be 1 gigabyte second. So 128 gigabyte seconds is actually a lot of Lambda. I think the P95, like 95% of Lambdas execute at the minimum memory or near it and less than a second. And so you get a ton of Lambda for this. But it gives you some wiggle room, but there are some constraints there, right? So what does that mean? So basically, so I started there with Lambda. And as I said, you can do this for any service, but the serverless services are a little easier to do. So what I did was I did this for Lambda. And then I did it for AWS step functions because I knew that machine learning was a pipeline or a set of steps of something. And then I did it for Dynamo because I love Dynamo and it's my data store of choice when I can store things. And so I did this exact same calculation using their pricing pages. In the end, the Lambda cost was an order of magnitude bigger than the others, and I think compute usually is. And so, you know, that governs that's the 80-20 for our entire system. However, the architecture kind of fell in around that. So this is the architecture that we ended up for our system. It is a lot of Lambda. It is a lot of step functions. It is some Dynamo. And it is some more Lambda for indexing. And then there's a couple of shared resources in the middle, an event bridge, event bus for pushing notifications around, and a Redshift data warehouse for doing queries. And I'll get in at the last slide, I'll talk a little bit about how you allocate that shared cost from that Redshift cluster. And also at the end, I can go more into detail about the actual architecture. But for now, I'm gonna just show this to you because it looks pretty. Okay, so great. We have an idea of how much we have of a given service. We need to fulfill our transactions requirement. And I've kind of designed this ideal architecture. But now we got to go to the code, right? We got to go to the code and we got to get that code into those Lambdas in theory, if I want them to be there, right? So that's kind of doing the hard work of getting that C code to be able to run on an embedded device. So how do we do that? Well, I give you 2 recommendations here. The first one is to be ruthless and ask a lot of questions of your data science team, the 5 whys, if you will, of why is this code? Why does this do what it does? What are you doing here? And then the second one, this screenshot comes from a talk, Building Composable Abstractions by Eric Norman. But the slide I highlight here is this idea of a physical metaphor, right? For those of us who build systems, we're often taught domain-driven design. Domain-driven design, your code and your system should reflect the domain that you're implementing. But what if you're not implementing an airline system that has what if you don't have a physical analog, some analog in the real world that you're actually implementing? What if it's just an idea from your data science team? Well, you have to pick some sort of physical metaphor so you guys can talk about how to build that system. So I'm going to give you an example in the next few slides of both asking the 5 whys and a physical metaphor that I think are applicable, and at least that's what we used when we were doing data science productization. But I want to take a quick aside here to say, listen, I get it. I'm not naive. I'm not saying that every valuable ML algorithm can fit into a Lambda. That's not what I'm saying. And I'm not saying you should try. What I am saying, though, is that you should spend time productizing your ML. And you should not accept when a team says, well, we need 32 gigs of memory. You say, well, why do you need that? Right? So, and I'll get into how you actually get into that. But in general, friends don't let friends write concurrent Python. So at some point, you need to ask some hard questions and you need to get down and dirty. So here's where I give you some concrete tips for productizing ML, the code itself, and at the same time, use a nice physical metaphor. So I alluded that I was an audio engineer in a past life. So I'm going to use audio. So, imagine audio signals, just waves in the air, reverting. That's kind of like your raw data, and you're going to capture it somehow. Don't mistake a data lake for a data warehouse, right? A data lake is it's just raw data. You shouldn't touch that right away. You should transform that into a data warehouse somewhere where it's easier, more queryable. But then after that, an important thing that people forget when you're productizing is to sample and quantize that data. So in audio, right? So like for a CD, for example, it's 44.1 kilohertz. It's a certain sampling frequency and 16-bit pulse code modulated audio, right? So there's some choices there about how to represent the data. So when your data science team says we need 1,000 data points per second or to do this transformation, you should ask why, right? Do you need a data point every second? Can you deal with a data point every minute? If it's not time-oriented data, you can still sample. Do you need all that data? That's one. Two, quantize, use efficient representations in pandas. It's really easy to just use a string or a float for everything, but you should use a byte where appropriate. You should use the right data format, the right data type, right? In the right cases. After that, filtering and aggregation. Again, when you're doing research, super helpful to be able to filter and aggregate group by in memory because that's faster. But when you go to productize, that's stuff that you don't need to do in memory on an EC2 instance or in a Lambda. That's stuff that you can pre-compute, right, offline, and then feed into a data warehouse, or just do it. Redshift is incredibly powerful. Just maybe offload it to Redshift. But don't just do that in memory because that's how research did it, right? Think about that stuff. Understand how you want to filter and aggregate. Use efficient formats. So do the right algorithm in the right domain. Do you need to convert to the frequency domain? Is it better in the time domain? Do you just need a capacitor to turn down? These are examples, maybe contrived examples there, but are you using the right formats and doing the algorithms in the right domain? And lastly, don't forget to prune dimensions. If at the end of all this is just a cassette tape with 2 channels, then you don't need all that data. But more specifically, I'll use a specific ML example, right? So decision trees are a really great tool. And when you start and you're doing research, maybe you have 100 dimensions in that decision tree. I'm telling you, you don't need 100 dimensions when you're productizing that ML, right? Because at the end of the ML is going to be someone or something that you're providing value to. In audio, it's always the human ear that you're kind of building for, right? So you're probably giving out a yes/no answer, or you're doing speech to text, or in a lot of cases when there's a human involved in your ML loop, you're outputting an Excel spreadsheet that they can review. Guess what? They don't want 100 columns in that spreadsheet. They want 2 or 3 that they can just quickly look at and decide if they should move on with their life. There's a domain in audio engineering called psychoacoustics, which is wonderful. It's what the ear, how it works, what your brain, your auditory cortex can actually hear. And there's a concept in there called masking, right? There's frequencies and amplitudes that mask. And you should think about that. What is the 80-20 in your data set, right? So what data actually drives the kind of results that you're looking for your business? Okay, great. We've productized, we've deployed to production, but now what? Well, I said before that we had 3,000 transactions. That's what we needed. I set this goal. I gave myself this procurement goal of $7 per day. That's what I wanted. Then we kind of from there grew out our architecture and used some very fine-grained tools and a nice metaphor to productize the system. And at the end of the day, you need to confirm that hypothesis. And here's where, I'll just give a slight shameless plug for the system I've been helping build for 3 years. I'm the longest tenured non-founder principal engineer at CloudZero. This is a tool that I use and I like, and it helps me do what I just explained, right? So a line of drink your own wine, or gin in Brian's case, kind of, case. So these are just examples from our platform. But the important thing is that afterward, whatever tool you use, you confirm your hypothesis, because I've told you that cost is potentially a good tool to start to constrain your system in the way that we used to do procurement. So you got to confirm that. You can't just do it and then set it free and then not know. So on this slide, you see us, the Sankey diagram in the top left, those blue lines, that's us mapping shared resources. So for the Redshift case I gave you before, you need to map a shared resource like Redshift. It's one of the hardest things to do, is to say, well, 10 features use this RDS instance or whatever. How do you map that? That's a case of us giving a proportionate cost allocation to a given feature for that shared resource. The views feature is something I just finished building, which allows you to kind of, I think someone asked about this before, but how do you give certain teams only the views that you, like the data that they want? Maybe they don't have access to the billing data. Well, here's a way to send a group of people a Slack message on just the data that you, the team says is okay for that team. And you'll get Slack messages based off of that grouping. And then finally, there's the Explorer just to see how daily cost is trending. In this case, this is the real cost of the anomaly system we built. And there were some spikes there, but over the last 30 days or whatever that is, 2 weeks, it's pretty much settled at $3 or $4 a day. So cost hypothesis confirmed. So let's just review. AWS service limits are not your primary productization constraint. You should know them. You should love them. You shouldn't bump up against them. don't build for them, just know them, but they shouldn't be your primary constraint. Use transactions to guide customer-focused design, right? Then use dollars to transfer those transactions into what you can afford of the different given services. So invert those pricing pages when you're building your system. When you're productizing ML, please ask that team a lot of questions. Ask them a ton of, and then ask them more questions after that. And then try to come up with a physical metaphor, because honestly, data science is hard and machine learning pipelines are complex and they are very confusing. And you're not gonna hold it all in your head if you know, even if you think you understand it. So come up with some metaphor to help you guide you in your productization. And the last part about this, as I said, operationalize your cost by confirming that hypothesis. Don't just set it free and then, 2 months later when they call you because you had an infinite Lambda loop that costs $10,000 that month. Don't just set that free. Confirm. Okay. Thank you everyone for your time. Here are some of the references from the blog post. Release It by Michael Nygaard, the talk I referenced, the high level HLA diagram I drew in this tool called Whimsical, which I love. And I always have to give a shout out to Simple Made Easy, that talk by Rich Hickey, because it changed the way I think about software.
Excellent. Thank you for a great talk. We're going to take questions, but also don't run away because we have 2 more raffle items. But let's do questions.
Let me bring up do I have the chat window someplace?
Adam, I had a comment just about Lambdas.
Sure.
I spent a ton of time in Lambdas as well. The pricing is often non-linear. I mean, a lot of our most Lambdas do run at the minimum size, and lots of them end up swapping. And when you take them from 128 to 256, you've increased the gigabyte seconds, but I've almost never seen it not decrease the duration by more than that.
Yes. That's an excellent point, Brian. So we just a quick note about CloudZero. We are completely serverless, right? So we have no non-serverless compute, except for a POC that we're doing internally to figure out if we can understand Kubernetes somehow. But no, but I mean but yeah. So we use serverless a lot, and you make a great point, Brian. Understanding the nuances of Lambda pricing and tuning Lambda is actually its own talk that I can give on a separate day. But one thing that's counterintuitive about Lambda is that you actually get, you only have one knob, which is the memory. But with memory, when you get to 1.7 thereabouts gigs, you get another CPU, virtual CPU, that you can play with all of a sudden. And also, right, you're getting proportional network throughput as you go up.
Yes.
So usually what's happening, Brian, is as you tune up that Lambda to like some sweet spot, because your Lambda is almost certainly calling S3 or calling Dynamo or whatever it's doing, right? And no one can convince me otherwise that network throughput is not the bottleneck on your Lambda, right? It's definitely the bottleneck on your Lambda. And what you don't realize is, you only need like even 16 megs of memory. You don't need any memory, but what you need is some actual network throughput to actually make the request. Yeah, so what you're describing, we see all the time, which is I will tune up a Lambda way beyond its memory requirement just to ensure that I get the network throughput that I need. Right. And in fact, the primary Lambda that we have doing our machine processing, maybe I'll go back to that high level architecture diagram if I can find it. There we go. So, most of our Lambdas are get config, decide which models to build. Those are tiny. And then we do a fan out with the map operation. And that's where we do the training and prediction. And those are tuned up to about 1.7, 1.9 gigs of memory. Not because it needs it. They only need about 400 megs of memory, but just for network throughput, because I am about to ask for a bunch of data and I'm about to put a bunch of data into S3.
Yep.
So
Adam,
Brian,
sorry,
just a quick follow-on, Brian, to that point. So one thing that I've done a bunch is, I'm not sure if there's something commercial or on GitHub that does this, but I built myself these little rigs so I could iterate through, measure performance, and basically build the graph for each fundamental piece of code I have, and then I can find that sweet spot that I really need.
Yeah, I built the same thing, Ken, and I think there is a GitHub Lambda pricing I'll find it and I'll put it in the AWS Lambda Power Tuning. That's what it's called. And it's a pretty well supported GitHub Lambda Power Tuning. Yeah, AWS Lambda Power Tuning. And so that's one where you kind of attach it to one of your real Lambdas, and it'll go through it'll do this kind of performance test where it'll scale up, scale down, and tell you what you need. But yeah, I've definitely built my own my own thing there too, Ken.
Adam, just question, since you're
Sure.
serverless, did you look at, instead of using Redshift, did you look at Snowflake?
Yeah, actually, so I'm glad you asked that question. So a couple things about Snowflake. One, I get a ping from them on my work email almost weekly. And we looked at Snowflake, and actually we are strongly considering Snowflake in the future. We're not quite ready for it yet, but it definitely looks compelling.
Yeah, we've been, because I've been using them for about 6 years at work, and Redshift, we've looked at other things. There's nothing even close to it. It's like truly serverless, and it scales up, scales down. And the Patriots, right? The New England team, they use Snowflake. So pre-game week, it automatically scales up to the maximum cluster size. And they just have 4 DBAs ingesting about 5 million events a minute.
That's awesome, Drew. Yeah, so we are definitely looking at it and considering it. Right now, we are, Redshift is our primary shared resource throughout our architecture, and so it is something that is scaling for us for now, but it is fairly expensive as far as managed services go in our architecture.
Yeah, that's true.
So that's an excellent point. So we're also doing some fairly complex joins. One really nice thing about Redshift, which I'm sure you can do in Snowflake too, is we do a lot of things we take advantage of Redshift external tables, right? With Parquet data that we just leave in S3. So that's, looking at how we currently use Redshift and external tables, and kind of we create materialized views on the fly in Redshift. So that's something that we just need to compare. I'm sure Snowflake can do it.
Yeah, Snowflake can do. So the other thing, I know you use a lot of DynamoDB. Have you heard of a database called Scikila? It's Michael Stonebreaker.
No, I don't know that one. I'll have to look into that.
So basically it's Cassandra compatible, and your actually Dynamo bill will come down significantly, probably by half.
That's it. I'll have to look at that. Our Dynamo bill is tiny now anyway, but we use on-demand pricing, which is about 7 times more expensive than the capacity plan pricing. But because our workloads are so bursty, we use it pretty efficiently. By the way, quick plug for Alex Dubri's DynamoDB book. If anyone, there's a great serverless community on Twitter and around the serverless DevOps days. All that stuff is awesome. And if you do use DynamoDB at work, pick up Alex's book. I was not paid to say that. I just think it's a great book.
Yep. Thank you.
So pretty much all our systems. Also, just one other thing I'll say, if anyone cares to listen. So there's a lot of talk of microservices and micro serverless, or how does serverless fit into that. We often have the blue, green, and purple boxes in this architecture, or might be what you might call like subcomponents or microservices. And we try to, every one of our microservices, quote unquote, kind of has an S3 bucket for configuration, a Dynamo table usually for doing some basic indexing for efficient lookups in whatever it's doing, and then a bunch of Lambdas just servicing internal or external API requests. And we find that that's a pretty good way to organize the system, with just one other thing added, which is that anytime you want to synchronize or send messages, we used to do it with SMS, but I highly recommend EventBridge right now. So if you're looking for, just when you're kind of in the event sourcing pattern or CQRS, when a serverless component does something, my suggestion is just have it publish an event to an event bus. Say, hey, this state change or this thing happened. And that way, if anyone else in any other subcomponent in your system cares about that, then it subscribes to that rule in EventBridge and then just mutates its state. It's a great way to synchronize services asynchronously without doing kind of, the SOA spaghetti where your services calls. So I definitely recommend looking at EventBridge, connecting kind of your micro serverless systems to each other asynchronously.
All right, why don't we do one more of the raffles and still think about questions. So this raffle This is also for one of the $25 Amazon cards. And the sci-fi geeky question is, which actress played a Cylon on Battlestar Galactica and also played the wife of God on Lucifer?
Which Battlestar Galactica series?
The real one, the second. Because the first one didn't have human form Cylons. Good guess, but no. With Cylon number 6 as a clue.
Alexa, who was?
No.
Don't worry, this isn't hooked up to anything. I'm telling you, these things just multiply and they just.
Yes, Robert, you're right. Yes. All right, so Robert, yes. So Robert wins. Robert, send me an email. I'll send you the gift card coupon. Okay, give it to your daughter. That's cool. And the last survey, so that was for the 25. The $75 is the question is hidden in the survey, and there's one of the question. And so answer here. One of the questions in the survey is about computer languages. Yes. Prakash? Am I saying that right? Yeah. So if I'm saying that right, Prakash got it right. Send an email, and I'll say it. It's actually, send it to Adam. Adam, you guys were going to do the slice card.
I don't know if I'm rated to give out free pizza, but I don't know if that's above my pay grade. But yeah, no, we'll figure it out.
Natalie's address is in the Slack. She's the big spender.
Okay, so Prakash, if I'm saying that right, send an email to Natalie, and you get the $75 slice card. Which and thank you so much. That's a great giveaway. I've tried to get companies. I've tried to get our hosts to do drizzly whiskey cards, but so far, even in these pandemic times, the lawyers have prevailed, saying no. But give us a few more weeks of the current madness, and sorry, I'm not even going to go there.
So Prakash, next time, join us in 2 weeks, and then we could watch you eat and savor your pizza, and live through you vicariously.
So, yes, and Adam, I'm guessing you can post the slides.
Yeah, of course.
One
Definitely.
of us, and we'll put it in the meetup, and
Matt slides too would be nice.
Yes. Oh yeah, absolutely. And we're still trying to figure out exactly what we do with the recording, but we'll figure that out.
We're going to try to put it on Twitch.
Yes.
Sweet.
Ken is going to put it on Twitch.
Yeah, but you got to send me the recording.
I will.
Anyway, we'll work it out.
I will.
And watch the Slack space for when we do that. That'll be the best way for us to communicate that it's up there.
Yeah. So any more questions? Okay.
Questions for Matt or Adam, for that matter.
Everyone gets one.
You hungry?
I don't even know, what time is it? Oh, okay, yeah.
It's 7:25, and it's funny. After our last meeting, we didn't close the meeting. We just sort of chatted until it drifted away naturally, which was kind of cool. I will say in 2 weeks, we're going to have a talk on IoT, including and I say Amanda because I don't want my devices to respond. So it's IoT and including Amanda. And then I believe the meeting 2 weeks after that, we're thinking of doing a series of lightning talks. So again, if you have, you know, a 10-minute talk you'd like to give, you know, please reach out to us on Slack or on the Meetup, because you give a 10-minute talk and you're a presenter as far as the resume in LinkedIn says.
So if anyone, I just reposted again the survey. It'd be great to fill it out, please. With, you know, hopefully this. I think these are great talks today. So thanks again to Adam and Matt and Natalie for helping to arrange from CloudZero. So thanks, guys. That was great. And you know, we're always trying to get this to be as effective and useful a forum as we can for everybody. So you know, let us know what's working, what's not working, other new ideas you would like to see. Just, you know, be creative. But you know, just speak up, and the survey is a great way to do it. You can also hit us up on Slack. So yeah, please take a moment to fill out that survey. It only takes like a minute.
I'm also happy to hang out and let the, you know, if anyone wants to talk or ask more in-depth questions in a smaller setting, I'll hang out for a bit, although I am going to go grab a tasty beverage and then I'll come back.
I left a message for you on your chat.
Oh. Nice. That's awesome.
It was a long time ago.
Yeah, Dolby. I think that was Ray Dolby came up with that algorithm. That was one of the first ones that they productized, which was really cool. So
I have a Ray Dolby story. I had a startup back in 1989. It was an aviation weather service, and this guy called up. We used to fax the weather out to people, and my wife, who was my partner, you know, was talking to this guy Ray Dolby, who we never connected, was, even though actually I have a digital audio background as well. And so my wife is lecturing to him what was going on with his fax machine and the technical details, and she was right, actually. And then we realized, like a week later, there was a full-page spread in Flying magazine with him in his jet. And we realized that, oh, that's really Ray Dolby is the same guy. And she realized that she's, you know, was lecturing this sort of famous Stanford PhD about electronics.
So. You know, it's funny because I'm sure most of us get questions from people about computers, and I'm like, I don't understand computers. I work in AWS. Like, I don't get it. So, all right, I'll be right back, everyone. Just give me 2 minutes to grab a beverage.
So, and before people go, the person who won the pizza said that she doesn't like pizza and doesn't have a venue to give them away. So, so I'm gonna on the fly here come up with a new question.
Well, Brian, just not to think out loud in front of, you know, 50 people here. Do we want to just swap that with one of the people that won the previous raffle?
Sure. Okay.
I mean, either way, it's just a suggestion. Just so
Robert, would you prefer a $75 slice coupon?
Let me ask my daughter. Hang on.
The reason I said that is because that way Prakash doesn't end up with nothing.
Oh. Okay. Yeah. Sorry. Would you like? Yeah.
My daughter prefers Amazon.
Awesome. That's kind of cool.
The pizza.
Okay. Well, tell you what, I can get more of the coupons. Prakash, I will get you an extra one of the coupons. Okay, fine. So we're still going for the pizza. The question, and you can tell that I'm a Battlestar fan. Which actor played Apollo in the original series and Tom Zarek in the new series?
Oh, jeez.
My wife for this.
Yes. Oh my God.
Okay. Oh, right.
All right.
Oh my God, he didn't even think about that. That was like typing immediately.
Okay, but, well, what does the group think? He already won the first one, so.
Yeah, no double dipping.
I don't know. If he gets it, he gets
He's
it.
worthy. Yeah, if he gets it, he gets it.
Then again, he did get it instantly. So
All right. He gets it.
Unless he's got Wikipedia open in his browser and he's got all the names right there.
Well, if you could search fast, you win. You deserve it.
Yeah, if you can search that, you can first.
Brian, you're going to have to come up with some other show to pull your questions from.
Yeah, Brian, I'm giving you the questions next time.
Doctor Who, man, Doctor Who.
Oh,
Yeah.
okay. All right. So, so Federico, send a note to
Natalie. Natalie.Jones.
Yeah, and she will hook you up with the pizza, and I'll hook you up with the credit. And Prakash, I'll give you another coupon, and Robert, you get a coupon. So it's all awesome. I mean, the nice thing is Amazon gives us as many of these coupons as we ask for within reason. Not the slice ones, but the other ones. So, all right.
Well, that's fun. So,
questions about music next time.
Oh, yeah, we could definitely do music questions. That we can do.
Maybe we should have some background music, some atmosphere.
Oh, I got some 80s music questions. Queuing them up next time.
Yeah,